Thank you. All right, so again, our last chapter. And honestly, a lot of the things we get to do in it, kids do actually find kind of the most fun of all these chapters we've recently been doing. Just kind of show you what it's capable of. All right. So in the previous chapters, we've talked about only being able to compare a proportion to a given claim or a proportion to one other proportion, right? Now, the cool thing about this chapter is it takes it a step further is we can actually compare an entire distribution to a claimed distribution. Okay, so it takes a step further. Now we're not just looking at one single proportion. We can look at many proportions at a single time and kind of avoid that problem we talked about earlier of having to run multiple tests, which you never ever want to do. This can lump sum many proportions together and analyze them at the same time. All right. And best yet, you can use M&Ms as a really good example of it. So, Mars Incorporated reports that their M&M peanut chocolate candies are produced according to the following color distribution. They say 23% of them are blue and 23% are orange, 15% are green, 15% yellow, 12% both red and brown. So, Joey bought a bag of peanut M&Ms and counted the colors of the candies in a sample. He got 12 blue, 7 orange, 13 green, 4 yellow, 8 red, and 2 brown. Assume that this represents a random sample of peanut M&Ms. And what we want to do is we want to discuss, does this data provide evidence that the color scheme of his bag differs from what Mars Incorporated says that the color distribution should be? So again, that's kind of the fun thing about this chapter. We can look at all of these colors at the same time. We can look at this entire distribution all at once rather than having to run a test per color, right? Because theoretically we could, right? We could run what proportion are blue, what proportion are orange, this and that. But again, didn't we say that's a bad idea? You don't want to do that, right? You shouldn't run more than one test. This kind of takes care of that issue, okay? That's what we do in this chapter. This first section, we call that a chi-squared goodness of fit test. All right, so it's a whole new branch of testing. So this whole chapter, you probably noticed on the cover, it's about chi-squared. You're going to learn 3 different chi-squared tests in this chapter. All right, again, first one being this goodness of fit, which kind of feels like chapter 9 did. Okay, chapter 9, you were testing your proportion or your mean against a given claim, something someone else says this is what it should be. That's what this test is, but dealing with a distribution, not just a single proportion or a single mean. Okay, now, even the null and the alternative are set up the same way. All last chapter, wasn't the null always that the two things were equal? AKA, what's another way to phrase that? If they're equal and then there's no difference, okay? So that same idea holds true here, okay? The null is always going to be this idea that there's no difference between your sample and whatever it is supposed to be, okay? Now, to get the phrasing down is actually kind of the opposite of what you'd expect. I actually start with the alternative, and then I just rephrase that into my null. All right, so here we're asking, is the color scheme of his bag different than the Mars distribution? Okay, that is going to be your alternative. The phrasing of the question always becomes your alternative. So in this case, alternatively, the color scheme of Joey's bag of peanut M&Ms differs from the stated color distribution, all right? Their phrasing becomes the alternative, and then you just want to make your null, you want to make it that there's not a difference. So oftentimes you're going to see, really, you have the alternative, and then if you add the word not somewhere, or changing differs to matches, that's how you get your null from it. Okay, does that make sense to everybody? Again, you'll get practice at that, but literally their phrasing makes your alternative, change one word in it to make it not the alternative, and that becomes your null. Okay, easy enough, right? Smile, not get, thank you. I'll say, smile, not give me something, guys. All right. Now, this, I honestly hate this phrasing of it. That's why I never actually make you do it. The only reason I show you this is because if they write out like a scenario for you in a multiple choice and they want you to do work with it, I at least want you to understand what this looks like. Another way to phrase this is you could actually explicitly say what the given percentages are. You could list out every given percentage, and the alternative saying at least one of those is not correct. Again, I think that is a very clunky way of saying this. That's why I will never ever actually have you do it that way. But it is a way that you could see in like multiple choice, something like that, if they're setting up a scenario for you to just work out a piece of the 4-step process, just so you're familiar with, that actually does say the same thing. Yes.
So would we be allowed to use that on like the AP test or like one of your tests?
Yes, I just think it's clunky, which is why I don't do it. Yeah, but it's not wrong. I just think it's more work than you need, and I think just rephrasing their own prompt is a much slicker way to get the job done. So that's our stage step. All right, just making the null an alternative and naming it, obviously. Plan step. What do we do in the plan step again? We check our conditions. Now, there is one caveat to that this time, okay? So random, we did say that it was stated we could assume that this was a random selection of M&Ms, all right? I'm going to bop around for a second. In the future, we'll go in the order we always have. Independence, is it safe to say the sample is less than 10% of all M&Ms out there? Is that a safe assumption? Oh, yeah. Now, notice this is called chi-squared, okay? This whole chapter actually involves a completely new distribution called the chi-squared distribution. So the one difference to this chapter, you actually no longer check for normality because chi-squared isn't a normal distribution at all. It never will be. Instead of normality, we have a new condition called the large sample size condition. Okay, for the large sample size condition, we're checking for all of the expected counts. Okay, what should we have gotten? And we need every one of those to be at least 5. Okay, so again, just a slight adjustment. Instead of normality, this is what we need to check for the final condition. All right, so let's talk about how to get those expected counts. All right, so looking at blue, okay? So looking at the blue, first off, how many M&Ms were in his sample? Can somebody do that for me really quickly? Does somebody have a calculator handy? What are all of those added up? How many were in his sample? 46? Excellent. All right, so 46 in his sample. For blue, it says that we should expect 23% of them to be blue, right? So if the null is true, we would expect 23% of these 46 to be blue, right? 46 times 0.23. So we would expect 10.58. I think, was orange the same? Yeah, orange was also, yep. So same value here, 46 times 0.23. Green and yellow, it says 15%. So we're going to take 46 times 0.15. We would expect 6.9 of these to be green and yellow. And then finally, was it 12%? Yeah, then 12%, so 46 times 0.12, we'd expect 12% of each of these to be red and brown, respectively. Okay? So for this, you need to find all of those expected counts, okay? And again, the actual check for that condition is stating that each of them is at least 5. Okay, so note here, it is okay. Don't we have 2 observed counts that wouldn't meet that? That is actually a very common trick they use on multiple choice to try to get you to say you can't do this process. But you can, because it's the expected column that you care about. Okay, so watch for that. That is a common trick they will try to use on you, multiple choice wise. Just make sure you recognize it is the expected counts you care about. And yes, every one of the expected counts is at least 5. Is everyone, again, you'll see that again in just a moment here, but is everybody okay with that new condition? Again, just a little bit of a mind shift. We're getting away from normality this chapter, and we have this new one we're going to be checking. But at least the other two are exactly the same as what you've been doing before. All right, so the idea of chi-squared, okay, the idea of what we're going to be doing is we're going to compare the observed counts from our sample with the expected counts that would be true if the null were true. The more that these differ from each other, doesn't that give more evidence against the null, right? If we're comparing these, the further these numbers are apart from each other, isn't that more and more evidence against our null value? Does that make sense to everybody? The more difference there are between the observed and expected, the more likely it is we're going to reject the null for the alternative that there is actually a difference in this distribution. How we calculate that is called the chi-squared test statistic. Okay, now I'm going to take a moment just to show you. Again, there's very few things you would legitimately have to memorize for this semester. So note, this page we've been using all semester long, very, very bottom of it, what's there? Chi-squared. So this formula right here is in the formula packet, okay? You don't have to have that memorized. It will be right here for you to use when you need to, okay, if that pops up for any reason. But just to practice how this works, okay, the chi-squared test statistic says take the observed value minus the expected value, square it, and then divide it by the expected value. What does this symbol out front mean? Add them all up. So theoretically, you would do this for every single term, okay, every single color. Add them all up. That gives you the chi-squared test statistic. Okay, so again, just a model. I'm not going to have you do this for every one of them, but just to show you what that setup looks like. For blue, that would be 12 minus 10.58, right? Observed minus expected, divided by expected. And then again, theoretically, you would have to do that for every single color, okay? So brown would be observed, which is 2, minus expected, squared, divided by expected, okay? And when you add those all up, that would give you your chi-squared test statistic. Another phrasing to be aware of is sometimes they will talk about which one has the greatest component, the chi-squared test statistic. So this would be considered blue's component, blue's contribution to the test statistic. This will be brown's contribution to the test statistic. Good news is you never actually have to do that by hand, okay? I'm going to glaze over that right now. You're never going to do this by hand. You will always use the calculator to do this for you, okay? So I'm going to jump into that right away for you so you can see just how this works in the calculator. Now, to do this in the calculator, doesn't the calculator need to know all of these values and all of these values to make this work, right? Won't it need to know literally all of that? Where might be a nice place? Lists, right? You have 2 lists of data. That's where we're going to ultimately put this, okay? I will need your help reading them off because I don't have all that memorized. So give me 1 second to get to the right place. I'm going to clear that out. Can somebody read off all of those observed counts, please? 12, 7, beautiful. And then was it 10.58 for the first 2? Oh, whoopsie. Then was it 6.9? Yeah. And what was the last one? 5.53. Or 5.2? 5.52. All right. So I'm going to put all this up in the 2 lists. My observeds in list 1, my expecteds in list 2. All right. Now, of course, if I'm going to run a test, where are all of our tests? Stat over. Now, to get to the right ones, I'm going to scroll up to find all of these kind of new looking ones that are at the very bottom of the list. All right. Now, notice here, there's two here. Now, notice the one that we're working with right now is called chi-squared goodness of fit. Which one do you think we're going to use? Yeah, or chi-squared GOF, okay? The GOF represents goodness of fit. The other ones we're going to work with later this chapter deal with the other one. Yes. It just, like, how good, or I hate that phrasing, how well does your sample fit the actual distribution? Like, how well do those match? That's why it's called goodness of fit. How well are you matching the given statement, the given claim that you're supposed to be? Ugh, gross. All right. So, now the nice thing is, when you try to run the program, doesn't it kind of remind you, hey, you should have stuff in lists? The nice thing is, as long as you know what test you're doing here, it reminds you to have those lists ready to go. Now, what's one thing you need to know that I haven't covered yet? Degree of freedom. Okay, so degree of freedom when it came for normal things, wasn't that just one less than the sample size? Same idea, slightly different. Instead of 1 minus the sample size, in this chapter, it's 1 minus the number of categories. All right, so I don't care about the 46 that were in my sample. I care about the number of categories I've labeled out for my stuff. How many categories are there? How many colors were there? 6. So what would our degree of freedom be? 5. Okay, 1 less than the categories that we have. Boom. So here is that chi-squared test statistic, that big thing we were making. That's what this is. What's this, as always? P-value. And then, of course, whenever there is a degree of freedom, don't you always want to note that in the do step, right? So you want all 3 of those things written down. I was hoping someone would ask that. So notice I said that each of those things we were calculating would be considered that color's contribution to the chi-squared test statistic. Okay, so I'll come back to this in just a second. I think I have a note about that. Yes, I do. Okay, so I'll come back to that in just a second. I do want to do the conclusion first, and then we'll come back to that. Concluding, what conclusion would we have if this is our p-value? We reject the null. So because our p-value is less than 0.05, we reject the null, meaning we have evidence of what? Oh, where is it? Yes, we have evidence that the distribution of color provided by Mars is not correct. That his sample was truly different than theirs. Yes.
So I know I'm probably already rushing, but I know if we use normal CDF to find the p-value when it comes to that, how do we do it with the chi-squared?
I wonder if there's a chi-squared CDF out there.
Is there?
Huh.
I
I feel like there is too, actually, yes.
Oh, wow.
Oh. That's weird. Okay, what was ours? 0.04. So that would round up to 5. Weird. I wonder when I was prepping these if I had typed it in wrong, maybe. I know. All right. Now, part B. So proportionally, which color contributed the most to the difference from the stated distribution? Sometimes this is called the follow-up analysis. So because we rejected the null, we do truly believe that there's a difference. And next natural question, which color is causing that difference, right? Which color is contributing the most to the fact that there's a difference here? Now, that goes back to those contributions, okay? So this list in the calculator of the contributions, this is saying proportionally how much is being contributed by each of these colors. Blue contributed 0.19 to the chi-squared test statistic. Orange contributed that much. Whoa. What was third on the list? Was that green? Whoa, green, calm it down. 5.39. Not as much, not as much, not as much. Okay, yeah. So which one is contributing the most? Green. So that's what that list is for you. Is it's just showing you which one contributes the most, which one is the most different. Here, green is contributing the most. Now, here, blue was a really small value, wasn't it? What does that mean if it's really small? Yeah, doesn't that mean that it was actually pretty close, right? If it's not contributing much to the difference, wasn't blue pretty close to what it was supposed to be? The observed and the expected were pretty similar to each other. That's what a small contribution means. It means that its observed count was relatively close to what we would have expected. Okay? Does that make sense to everybody? Yeah? All right. And of course, errors, if we're testing, aren't errors still a thing in this chapter too now? So based on your conclusion, which error was it possible to have made? Type 1 or type 2? Type 1, because we rejected the null. And if rejecting was wrong, that would be type 1, wouldn't it? In context, what would that mean for us in this case? Yeah, so it means we concluded that there is a difference in the distribution compared to what Mars says that it should be, when actually there isn't, right? Isn't that what a type 1 error would be? Yes. I'm not sure how I feel about the jalapeno one though. I haven't gotten up the courage to try it yet. All right. So let's try another one. After playing a dice game with a friend, you suspect the die might not be fair. You suspect some numbers may be rolled more often than you would expect. To test your suspicion, you roll the die 300 times and record your results. Do these data provide convincing evidence that the dice is not fair? All right. So again, spoiler alert, everything's a section is goodness a fit, okay? Because aren't we testing this distribution compared to what the die really should be? And on that note, what should the die be? If it's a fair die, what does that mean? Yeah, every one of them should be 1/6, right? You'd have a 1/6 chance of getting any of the numbers, right? That's what a fair die would look like. So that would be your given distribution this time, is that it's uniform, right? 1/6 all the way across. So the way that this is phrased, again, wouldn't this be the alternative? It not being fair, that is the alternative. And then the null, the opposite of that would be that the die is fair. So again, that's the pattern we always follow. Their phrasing, their question is your alternative. You just change it so your null is saying the opposite of that, whatever that means to you. Sometimes it means inserting the word not. Sometimes it means taking out the word not. Whatever it means to make it the opposite of, that's how you make your null. All right, plan step. 2 of the 3, the same we've been doing for months now, okay? Random. Is rolling a die random? Yes. So in that case, I know it doesn't say random, but realistically, if you're rolling a die, don't dice lead to randomized results, right? And now, instead of normality, what do we check for? Nope, large sample size. So large sample size is taking the place of normality, okay? Now, in this case, okay, we rolled the die 300 times, right? So for a large sample size, don't we need to check all of the expected counts, what should have happened? Um, what would the expectation be for every single one of these? What proportion? 1/6. So 300, we're expecting 1/6 of them to come up as 1. So wouldn't that be 50? In fact, wouldn't literally all of them be 50? Right? Every one of them, 300 times 1/6. If the die is fair, it should have come up 50 every single time. Does that make sense to everybody? That that's what we would have expected if the null were true? Now, to save yourself some space, what I oftentimes do when I can, when it's organized nicely in a table like this, oftentimes you'll see me say, accepted counts are written under observed. All of them are at least 5. Then you don't have to rewrite it in the body of your 4-step process. Again, just a way to save space if you choose to do that. If you want to rewrite all those values in the middle of your plan step, that's fine. I think this is usually easier. Just line them up for yourself. And dice rolls. Now, in this case, this isn't really a sample per se, right? You're just rolling a die. And isn't it kind of a assumed thing that dice rolls are independent from each other, right? One roll doesn't impact your other roll. So this is one circumstance. It doesn't really fit either of the ways we usually check independence. It's just a common fact. Hey, if I'm rolling dice, those are independent from each other. Okay, so this is one exception where it doesn't follow the normal pattern for independence. All right, so in the do step, this time our test statistic is that chi-squared test statistic. Now, in this first section, and you know I'm going to drop this later, but the first section, just to get you familiar and comfortable with what it looks like, I am expecting you to show this to me in this first section. Later in the chapter, we'll drop that off, just like we did in chapter 10, when I'm comfortable that you know what it looks like, okay? Because again, in case they were to pop up in multiple choice, I need you ready for that situation, okay? So that chi-squared test statistic, it says for every single category, take observed minus expected. So for the number 1, that would be 42. We expected 50 divided by 50. I'm also not going to make you do all of them. Okay, that would be an awful lot of writing. But at least show me the first one and then the last one. So 6 came up 44 times when we would have expected it 50 times. So again, each of those represents the contribution of each number towards the overall chi-square test statistic, which again, you'll never actually have to calculate because doesn't the calculator do that for you, right? Now, again, here, I have this information that the calculator is going to ultimately need. How do I type in that information? Where do I put it? I put it in lists. Oh, let's clear that out. Clear that out. 42, 55. And then every single one of these looks like that. Okay, so just put your observed and expecteds into your lists, and now we just run the program. Really easy to find because it's the only one that we know that's chi-squared at this point. List 1 and list 2. Aren't there 6 numbers on a dice? So there's 6 categories we're using. And our degree of freedom is 1 less than that. So isn't this 5 still true? Right? Run the test. So here is our chi-squared test statistic. Here's our degree of freedom. Here is the p-value. All right, and notice our p-value this time. What do you notice about it? It's greater than 0.05. And what does it mean when we get a p-value greater than that 0.05? Fail to reject. So here in this case, we are going to fail to reject. Okay? That means we don't have evidence that the dice isn't fair. All right. This time, based on the conclusion that we just made, which type of error could we have made? Type 2, because we failed to reject the null. We didn't conclude the dice isn't fair. But what if that was wrong? Okay? Isn't that how we would interpret it also? That the type 2 error would mean that we conclude the dice, or we don't conclude the dice isn't fair when it actually is unfair. That's what the mistake would be. And then interpreting p-value. All right, so interpreting p-value, again, generically, what does it look like when we have to interpret the p-value? As at least as rare as ours, right? All right, so the null being true. So given the dice actually is fair, that 0.06 whatever is a probability. Now in this case, I actually am not the biggest fan of the way that our book does this. They just kind of generically say of getting a chi-square test statistic at least as big as ours. That's just always their generic way of interpreting it, instead of diving in. So in this case, that's how they would discuss this. Okay, given the dice is fair, that's the probability of getting a chi-square test statistic at least as great as ours. Now, in chi-squared's case, it's always going to be at least as great as ours, because think about the formula. Okay, so notice in the formula, we're squaring these differences. So would you agree, won't chi-squared always be positive, right? So the more rare we get, this is just getting more and more positive, right? There is no negative side to chi-squared. So that's why it's always phrased this way, because simply the bigger chi-squared gets, the more evidence you have against your null. And happy Friday, guys. We're already done. Isn't that lovely? Do we like chapter 11 so far? Because I like chapter 11. Well, no, not because it's short, because it's fun. No, because it's fun. Okay, you have to make it also fun and easy, right? note, then I guess.
I have a note for you.
Aw. What's the note? What? Oh. So you don't need it?
I don't need
Oh.
rude.
Gosh, Haley, you're just using him.
Thank you.
Oh, then maybe he would have known how much you're already loving chapter 11.
No. I mean, I don't mind it.
Oh, I've been waiting for today.
I mean, whatever makes you happy. Gotta make a summer plate too. You're not gonna say that. Nikki's was good. She went to St. Francis. Oh, the street. Yeah, like the weird one.
What? No, I mean, I don't like having sassy girls over there. But I enjoy whenever I get to give
I'm
people.
sorry that I said that because now you're just thinking. I'm gonna make a summer plate. Have you guys been to like the Logan?
Logan, with those octopus arms.
You finish your what? Love it. I love getting words from my kids.
It might be chapter 9, sorry, but. See that 9% again, Pesh?
Even with you miss putting in one of yours. I know. I contemplated, like, I really looked. I'm like,
Okay, yeah.
okay, like, if I can tell you for sure meant to put that,
Like, look
I
at.
would give you credit. But when I looked at it, I couldn't tell if you were trying to cross out C or if you were
I
circling
know.
it
Yeah.
more. So I'm like,
So
oh,
there was.
I wanted to give it to you, but like, I couldn't tell.
I get you, but yeah.
I mean, because I really wasn't happy. Like, if
So
you
I think those are
clearly-
my last two I've turned in.
For 9?
Chapter 9.
Okay.
Oh, and maybe this. I don't
Oh,
know.
because these two things go hand in hand. So I'm
Okay.
guessing if I need this, I also.
I might have turned that in because I got like half points for those two.
Oh,
So just take
okay.
just to make sure.
Yes.
And then I'll get the chapter 2. So yeah. But guess what?
What?
So I had baseball tonight at 4:30,
Okay.
and I was supposed to work at 5.
Whoopsie.
So I just texted her and said I was sick, made it up. And I just said I caught something from my house. And my last day is supposed to be Sunday at Broadway.
Okay.
And she's like, well, we'll just cover your shifts this weekend, so we don't want to get anyone getting sick. So
Oh. So
I'm
free
done.
weekend.
No, I'm done at Broadway. 2.5 years.
Is it kind of sad or
I
are
don't
you
know
over
how I
it?
feel. Like,
You do you, Haley.
for 2.5 years, it's kind of weird.
It's a solid streak
And I'll,
of
like,
high school work.
My only job I've ever had.
Really?
Yeah.
I was Subway in
Yeah.
high school. That was my first
I
job.
don't know, I just feel weird. Cause like I'll never like, I don't know.
Well, I mean, in summers you could always go back.
No, I'm not going.
No, okay.
No, I told them I was hands down. I'm gonna work.
Broadway?
I'm done, Megan.
Yeah, you wanna know what happens this
No,
year?
Megan, I'm done.
No. Yeah, I
He,
know.
Like-
I'm telling
he
you.
told me what happened.
Like,
No. Oh my god.
my last week's supposed to be this Sunday. I'm not gonna work this weekend.
No, I'm telling you, Ashman what happened. So AJ, there's this food I really like from Broadway, and it's called Cinna Steak, and they're literally my favorite. And my dad has some company, and AJ's like, if you get me a sweatshirt from your dad's company, I'll
My
give you
sweatshirt was
Cinna-
cooking. I have it back.
I'll give you.
Yeah, whatever.
He's
I have
like-
a sweatshirt.
I'm
Wait,
talking about
Tash.
AJ's like, I'll give you Cinna Sticks like whenever you want. Oh, so I go in once to get them, and now he quit. So now I'm never gonna get them ever again. And I gave him a sweatshirt for one Cinna Stick.
All you gotta do is How much do you think that sweatshirt cost, Chad?
Like $50.
That means Liam Neeson starred in Tooken.
Yeah.
In Tooken 2. No, but I'm done.
Are you sad?
Oh.
I'm so sad.
I don't know how I
Can't
feel.
forget.
I don't think it's gonna be sad till I go in there and get my check.
Then you're like, oh, no more
I'll
money.
be like, then they'll say don't let this
So leaving Subway for me was like the best feeling.
Yeah.
So I worked there all 4 years of high school.
Yeah.
And then when I came back from my first year of college, I'm like, well, I want to make money over the summer, so why not? Well, they ended up, it was a new boss that worked there, and I ended up keeping the new boss. And they were hiring, like, teenagers. Like, remember when I was, like, 19 at the time? They were hiring younger teenagers for more pay than I was getting after 4 years.
Yeah.
So I was happy. I'm like, all right, peace out.
See, like, yeah, because I only got one raise. And I was kind of getting paid close to the same as kids who would work there barely a quarter of the time as me. And I could like different because it was like a bar, so I like knew all the regulars and stuff. So I knew a lot of people that like came into the bar. And, like I got super
Which
close.
actually probably made it fun.
And
Like,
I
seeing
worked
people
with a
close to
lot of
you.
the same people for like 2.5 years, so you get like close with them. I worked with Cole's older brother.
Oh, really?
Yeah.
Wait.
I'm like Cole's other brother.
Wait, there's another?
There's two older ones. Mason and Cole are the youngest two.
Oh. I didn't realize that they had older siblings. I thought it was just you and Mason.
Zach's 31 and Seven's 28.
Oh, wow.
Yeah, it's by a long shot.
Wow.
No, I like grew up with them. I'm like the fifth child.
They don't look like me and Mason either. Me and Mason are the only guys with red hair in our family.
No, yeah.
Interesting.
Because like Zach's got like brown hair, doesn't he?
Who is this? He's got like your hair but lighter.
Yeah.
And Seth has pitch black hair.
Carter Reichert.
Yeah.
Bye.
But Seth is like.
He also.
They're both pretty
he also
tall
has
though
his
too.
foundation.
Zach's like my height and Seth is like taller.
Seth is my height.
Yeah. I'm taller than me, so.
Just always if I imagine him, he's taller because
Just slap Zach's ass and walk out of there.
Like if you flip it over.
they'll say don't let the door hit you on the way out.
Yeah.
Or you have to put your shirt up in the ceiling. 'Cause that's the.
Well, I'll give you a clue. He's in my friend. So if it gives you a hint. And then is the plan still test? The notes took a little bit longer than I expected. There was actually a couple twists and turns in them, but I was still done like halfway through. So just depending on how you feel, if you want a little time to read, I've done like within half a fifth hour. So it becomes like half a fifth, and then you just take it. You only have half an hour anyway. Then you could still be done like easily in like 15 minutes or 20 minutes of 6 hours. Okay, if that works for you. Love it. I've been so excited to start this set. Yes. And I actually changed it because again, I hate the book. The way that they do it is they actually take a whole day before even showing you how to do this. They make you find out everything by hand. Like, here's this
How
piece,
it
this.
always has been for like all math classes, I feel like. Like, you'll do the lesson and you get this like homework summary and you do like 50 questions by hand. And then the next notes is like,
By the
oh,
way.
there's a calculator thing that we can do. It's like,
Yeah.
oh, okay, just do that.
Yeah, so I just grabbed that. I'm like, no, this is stupid. They'll never do it this way. Why on earth would I show them this way? And then I rearranged a little bit. So like the chi-square CDF that Bart was asking about, the book starts with that. I'm like, but that makes it sound harder than it is. I'm like, so I do that tomorrow. I'm like, oh, by the way, here's a thing in case that ever pops up that you may need to know. But it fits in because now you guys are really good at TCD and CDF. Like, so you should kind of pick up on it. So yeah, I really like this stuff. And I felt so accomplished in getting this right. It's
When you have to
beautiful.
grow your beard, are you gonna like just keep it all grown, or are you like gonna like line it up a bit so it's kind of clean, like so you're not getting a neck beard and like oh you're planning to do
I
with
mean,
that?
for you, I was just gonna let it grow and show you like the full potential of Tessa's growing ability.
How long does it take to be able to like a noticeable like it'll be kind of full?
Oh, you'll notice in a few minutes. I was gonna ask you though, because I'm leaving for my cousin's wedding next Friday. Well, no, I was gonna say, can we wait till I'm back from the wedding and that starts the 2 week clock? Would that be fair? 'Cause I'm like, I don't want to go and like scare my little cousin. Like, who is this?
Yeah, I know.
I figured you'd probably be okay with that because I feel like I should probably wait you some good stuff.
Yeah, like the summer vibey stuff.
She don't use jelly.
Oh, I'm so excited. I was looking at like, the temperatures. They're already in the 60s in Tennessee.
I'm
Oh,
It's supposed to be 50s
soon tomorrow.
tomorrow.
Yeah. So, gonna make some really nerdy, but if you already know this about me, that many of my friends and I still enjoy Pokemon Go.
Oh,
Because
yeah,
like
you want
back when the game came out, literally that's what every 10-year-old boy would have wanted. So actually, I feel like the game is more for our generation than kids today. Like people my age love it because it's what we would have.
I mean, if you really want something to make your day,
And
just
it's
picture me
super-
and Adrian Payne.
Wait, hang on.
And it's so nice that we're not going to MOA for tomorrow's event. We're
He was in
actually
the
going
airport and then
Yeah, I
I
heard the story. Good
in
content.
It's hot spot.
AJ, if you're done at Broadway, does that mean you're going
It's so
full-time
much more
spike
fun
ball?
outside.
Yeah.
You're going pro?
Like, kind of we do MOA just because we have to all winter long, but it's so much nicer.
I don't know. I felt like I was really good at
That's kind of the
spike ball
point.
until I saw Robert
Is to get
Gronkowski play
people
spike
out.
ball.
We have spike ball shorts. Yeah. Vision one. Look committed.
Spike ball player. You
I've
ever played
tried
spike
spec
ball?
ball.
Perfect summer
Gosh,
sex.
I almost hit someone in the face. Probably.
You're a spike ball player.
But so I'm hearing it'll be at your grad party.
Yes.
Go on.
So we
like
can
I'll get
play.
you June
I
29th,
like how you
2 to
grabbed
5.
literally the only
I'll get
part
you
that wasn't
when
beer.
my
You
grad
grabbed my
cards. I'll
neck.
give you one. So it has the address on it. Because I live. It's at my dad's
Yeah, we
house and
gotta
he
start
lives out
doing
by.
that.
Yeah, I say actually, as I start getting grad invites, I just line
So
my
yeah, my
door.
dad's house is kind of out by like Zimmerman. So it's bad.
And I'm impressed you already have them because the running joke I always have is I always get all the girls,
Well,
and then I always joke I'm like, dude, none of my guys like me.
we're trying to figure it
'Cause
out.
it's
Trying to
all-
figure out quick as baseball.
Oh
So we
yeah.
gotta like find a day fast.
Yeah, we're supposed to figure out
June
why.
15th, the seashell.
I'll make it like 24 by 36.
Oh, do you know Lily Fesh? Anderson?
Yeah.
So her grad party is right before mine, and it's on the way to my house. So
Oh hey.
kill two with one stone there.
As long as Lily wants to invite me.
Yeah.
Actually, it's really funny. 2 years ago, when I was out at grad parties, I kept getting invited to more grad parties
Yeah,
because
so you
kids would
never went
see me.
home.
They're like, "Ash, will you come to mine?" Or sometimes we out and about, and then I get a snap like, "Hey, just come over here too."
Yeah.
All right.
Well, mention it's my dogs too. Oh, I don't know if they'll be there.
I love dogs.
Have I ever showed you my dog?
No.
Have I ever showed you my senior picture?
No.
Oh goodness, this is not good.
I actually, so my vision, I haven't done it yet, but what I want to do is I've saved every grad invite I've gotten. And what I want to do is actually like take like fishing line or something and like string it through the ceiling and like just line my ceiling with all the grad invites from my kids. Oh, that's a really great picture.
And so, and then I'll just.
That's my dog Bella. That's my mom. That's my mom's house. But those three are at my dad's house.
Okay.
That's
Adorable.
That's George, Willie, and Hank. And then Bella.
Oh, that's a really nice picture.
Those are my favorites.
I love it.
The first time I went over to your dad's house and there was like 12 dogs and I had to
So, because my dad's girlfriend has three dogs too. So we had like 6 dogs in the house. Yeah. And they're like little dogs compared to like big dogs.
So my mom and sister have 4 dogs, and now they're fostering more. So they're getting like 3 more little puppies.
My mom like fosters random dogs and I'll like come home and it'll be like Bella.
Aren't I just like a
Giant dog there. And I'm like, I don't know who you are, but hi.
It's funny because like so my sister doesn't like when I come over because being around me is my energy and I don't have. But my mom like wants me over so she can get like other insects than my sister. But like it's so stressful whenever I go over because there's like all these dogs like all the time, they're just barking like crazy because they never see me. And so they're like, David, you should come over to my room and do this and this and this with us. I'm like, that's right. I don't want to be stressed out. And I'll be in Tennessee for fun. Like, hey, it's actually sad though that they don't want it. Well, because it's that side of the family. Like,
Oh, I thought we got on it.
Oh yeah, you all like trap.
Pashman, can we use the bathroom?
yes.
Thank you.
But yeah, and so neither of them are going to the wedding. I think my mom is at least going to the one in the summer. My cousin is getting married in Madison, so I think she's at least planning on going to Madison.
That's what the syrup was. It was Logan's coffee. We got it from the same place. That's why.
So he smells like
I forgot what kind of coffee he said.
it smells really good. Oh, is it hazelnut?
Like Dunkin' Donuts.
Oh, I love Dunkin' Donuts.
The donuts are very good. They're not fluffy and stuff.
Oh god, I remember when Krispy Kreme came out, and that's all Krispy Kreme is. It's like fluffy soft, but it's like doesn't fill you up at all.
I've only been Krispy Kreme once, and it's because we were in Vegas and we got like a free dozen with like our room. We went there and just walked with a dozen and like,
So it like if I recall correctly, I think Krispy Kreme started becoming a thing when I was in middle school, and everyone went crazy for it. And
is
then
there
they're
any
like,
near here?
there used to be one on Maple Grove, but it closed. Wait, I was like, this is stupid because you eat one and you don't get to eat anything. Yeah. So like, no, it's stupid because if I eat something, I don't want to sit down. Why did I say that?
Took her back there a lot.
I actually appreciate
Yeah,
that. That's
yeah,
funny.
I drew a foot.
I appreciate the honesty.
I do too. That was really cute.
Okay, have a great weekend, everybody.
Right now.
Oh, darn it! I was just a good job passing these out, then I got distracted. Where's Allie when I need her? No, actually, where's she been all week? Does anybody know?
No idea.